Okay, welcome to lesson 63, estimate percent. So this is another percent lesson. So I suggest you go back to the beginning of the percent videos and watch them. Okay, here's our objective, some vocabulary, some rules and notes for you. Okay, estimate 20.27% of 8380. So we're going to round this to 0.3%. And if we run through our threes, we got to get to a lot to get into the 80s. But let's see. 3 times 20 is 60. 3 times 30 is 900. 900. 29 is 87. 28 is 84. So if we do 8,400, let's round that to 8,400. We should come out with nice round numbers. Okay, so 8,400 times 0.003. And if I'm moving a little fast for you, go back and watch some of the earlier videos, please. 0, 0, 12, 1. 3 times 8 is 24, plus 1 is 25. Bringing it over 1, 2, 1, 2, 3 places. So 25 is roughly 3.3% of 8380, roughly. So remember, this is just estimation. We're going to make nice round numbers to whole numbers to round to. Okay, so this one is a little funny. So now, we know that jobs is the whole. Because let's think about this. No matter how many people apply, there are only a certain amount of jobs. So 920 is going to round to 900. So that's our part, because everybody doesn't get a job. Out of 338, we got about 300. We're going to round that to 300. And so now we're going to be dealing with 9 over 3, which is 3. So now, on the next video, so on this page here, we had 9 over 3, which was 3. And so to change a decimal, change a whole number into a decimal, add a decimal at the end, and we got to multiply by 100 to get a percentage. So of a job, 300% people apply for a job, which means that 3 times as many people applied for the amount of jobs that were available. And this is what happens in real life. You get a lot more people applying for jobs than actually get jobs. So here's an example of a percentage bigger than 100. 100 represents one whole. So let's look at our third example. A team lost 41, or about 19% of their games. How many games? So how many games did we have? So question mark times 19% equals 41. So 41 were the losses, 19% of the total. Okay, so the total, we don't know. So you can divide both sides by 19%. And that becomes 0.19. So we're going to change this to 40 over 20. And then 40 divided by 20 is roughly 0.19. 20 and a 40. Move the decimal twice. Move the decimal once, twice. 20 goes in a 40 once, twice. And we get 200 because 2 times 20 is 40. 0, 0. Okay. So 200 times 19% should get you about 40. That's a lot of games to play. 200 games. Okay. But maybe it's over a couple of years. Let's look at it. Okay, here's something very common. Estimate 15% of a tip on a bill that is $38.75. So we're going to round this to $39 even. Let's round this to $39. Okay, so you can break numbers. We're not going to deal with the percentage right now. You can break, let's break 15% into 10% and in a 5%. So we know that 10% of 39, 10 times 39. So I'm going to do this in a way that's going to help you understand how to do this quickly, because I could have did 15% of 40 and we'd have got close, but I'll do that on the next slide. But this is a different way. It may take you a little while and a lot of practice to get this one, but 0.1 times 39 equals 3.9 or 390 because we're dealing with money and we have to go out to the 100th place. Half of 390 is, if you divide that by 2, you get, if we divide that by 2, 2 goes into 3 once, 1995. So since 5 is half of 10%, 10% of $39 is $3.90. 5% is $1.95. We get 5, double that up, 18, $5.85. So the tip should be about $5.85. So that's one way of doing it. It seems like a long way, but it may be easier to work with 10% of a number than half of a number. So on the next page, I'm going to do it a little different way. All right, so if we're dealing with a tip, we could take 15% times 40. And we're just estimating here, so we don't have to get exact. We can get close. So 40 times 15 will give us 0, 0, 2, 0, 4. Will give us 60. And we have 2 numbers behind a decimal because 15 changes to 0.15. So it's about $6. So between $5.85 and $6, the only difference is 15%. It's not that much, so you can see that that's close. All right, so we got one more. 6% and $894 is so close to 900. We're going to do that. So we're going to take 6% of $894. And these are numbers. If you work with nice whole round numbers, 0.06 times 900, you'll make yourself very happy. So moving the 2 numbers over, $54. So 6% of an $894 laptop is going to be very, very close to $54. Okay, those are examples. I will see you at the end of the video for the recap. Okay, 190 is roughly 200% of times, of means times. So this 230 is already a round number. It's already rounded to the 10, so let's just leave it like this. Converting 200%, we divide by 100. That gives us 2 times 230 gives us 460. So 190% is going to be very close to 460. 1/48 is R of multiply 52. So all you got to do is convert the words into. So divide both sides by 52 over 1 divided by 52. Okay, so when we divide 148 divided by 52 over 1, we get 1/48 times 1 over 52. We're going to approximate. That's what these funny little equal signs is. Whenever you see a curvy equal signs, it means is approximately. All right, I'm sorry, I fat fingered that. All right, so it's 150 times 150. And we know that 5 times 5 is 25. 0 times 0 is 100, so 1 over 2,500. And now we have to turn this into a percentage. So 1. It goes into 2,500 goes into 1 0 times, goes into 10 0 times, goes into 100 0 times, goes into 1,000 0 times, 10,000. Let's try 10,000. 4 quarters is $1, so 1, 2 is 100. Okay. So multiplying. So now we had this number 0.004 times 100 becomes 0.04%. So that was a lot, but this is how these problems go. All right, let's look at our next problem. 29, we're going to change that to 30% times B equals, let's just go to 30, a nice big number. So 0.3 times B equals 30. Divide by 0.3, divide by 0.3. B equals I'm going to take a shortcut here and cancel these 3's out. And I'm going to get 10 over 0.1. And I know all I have to do is move the decimal over in the top, so it's about 100. So 30% of 100 is about 33. So 26.5 is close. Use the break apart method. So I'm going to take 10% of $80, which is going to give me $8. And then I'm going to take 5% of $80, which is half of this number, which is 4. So the tip will be $12. So this is a little bit of a mental math deal, but if you make it a nice round number, you can get yourself close. Or you can go ahead and do $80 times 15% and get an actual number. And you get the same number. And you should probably throw in a couple more pennies because the $1.25 is a little bit more than 80. Okay, use the 1% method to estimate a 7% tax, sales tax on $123.94 grocery bill. Okay, so the 1% is a fancy method. So watch this. This is real easy. All right, so let's round 123 94. Let's just round it to 120. $120. So let's take 1% of that, which is moving a decimal over once, twice. Once, twice is $1.20. 10% would be 12. 20%. I mean, 1%. Yeah, 1% is 1.2. So we know that 1% is $1.20. 7%. If you multiply this by 7, you would get $8.40. So the tax would be $8.40. So let's do 120 times 0.07 and see what we get. And we get the same thing. We kind of did the same thing. The 1% method works if you want to get really precise, but if you round up what your base is, then you can just multiply whatever your percentage is and not use the 1% method. I didn't really define the 1% method well. So if you had problems with problem 5, don't worry about it. Basically, you break any number down by 1%, and then whatever your percentage is, you just keep multiplying until you get there. So if I would have took 1% of 123 and 94, it should have been 1.2394, and then if I wanted 18%, I would have just multiplied that percentage by 18. That's all you do. I wouldn't worry about that too much. You can just estimate, like I said, the one number that you have, and then multiply that by whatever percentage. You get the same thing. It's just a different way of doing it. So that's this video, estimating with percents. If I went a little too fast, go back and watch some of my earlier percentage videos, and please watch these in a series. Okay, thank you for watching. Like this channel, subscribe, and hit the notification bells. Thank you.